Okay, so when you're going to complete the square, you want to have a leading coefficient on the x squared term of 1, which we already have, and then when you complete the square, you want to keep all the x's on one side and move everything to the other side. So I'm going to add 3 to both sides. Excuse me. So then you have x squared plus 8x, and then you're going to leave a space, and you're going to have equals 3. And I'm leaving a space because in order to complete the square, you take the b value, which is the coefficient on just the linear term, the x term. So I'm going to take b, which is 8, and I'm going to divide that by 2, which is 4. And then I'm going to square that. So this is 4 squared, which equals 16. You take 16, you add it to both sides. So the reason you're adding this number is because you're creating a perfect square. The perfect square is always going to be x and whatever b divided by 2 is. So I'm going to write x plus 4, and it was a positive 8 divided by 2. So that was positive 4. It's going to be a positive 4 in my perfect square. So I write it as the quantity squared, and that equals, and I simplify the right-hand side, which is 19. Now I'm back to solving by taking square roots. So I take the square root of both sides. So I'm left with x plus 4 because the square root and the square cross each other off, and on the right hand side I have to consider both the positive and the negative. Square root of 19. 19 is not reducible, so I'm just going to subtract 4 from both sides. And I'm left with x equals negative 4. We usually write the constant part or the integer part first, plus or minus the square root of 19. So I have two solutions, x equals negative 4 plus square root of 19, and x equals negative 4 minus square root of 19.